so we're gonna work through some homework problems together, and take notes as we're doing it. Okay. The first part of your homework again is just the simplifying. It's review, but it's you got some things to think of. So like on the last homework you had a cube, right? It was a number 5, I think. You saw doing that. This one is going to be like that. It's already written out, so you just got to take your time with the multiplication. So you've done stuff like this, but be careful. You can make some mistakes on 1 through 5. So the new part here is the 6 through, the numbering gets weird, sorry. After 27, that should be a 28, not an 18. That's 29. And then you're going to have to change all this, and so on. Okay? But it's not new, but there's only one thing I really got to get across today. We've learned all the factoring. We've learned everything new that needs to be learned for this unit. But the new thing that I want to talk about is when you factor, and you did a little bit on the last homework, when you factor, keep factoring until you can't factor anymore. That's it. And so I'm going to work through quite a few problems with you, just to give you a sense of what I mean by that. And you're going to be using different, this is all mixed now. You don't know what kind of factoring it is, and so it could be the GCF, it could be the factoring by grouping, it could be factoring trinomials, it could be difference of 2 squares, it could be sum of or difference of 2 cubes, right? So those are all the different kinds of factoring that we've done. So it's all mixed together now. So let's start with number 6. And the very first factoring you always have to check is look at all your terms and ask, is there a greatest common factor? So I see a 5c squared and a 125, and I could divide both terms by 5. So I factor out a 5, and I divide each of these by 5, and I'm left with a c squared minus 25. And so we just did the GCF factoring right there. Right? Now, don't stop there. You got to ask again, is there anything else that we can factor? So you have 2 pieces here, and it's a difference of 2 perfect squares. And yesterday, that's one of the types of factoring we saw, and that's the one we're allowed to take a shortcut. Yay! And so we can factor, leave the 5. Don't forget about the 5. Carry the 5 down, and then the c squared minus 25 factors, well, c times c, and 25 is 5 times 5. One with the plus sign, one with the minus sign. And there's your answer, because no. And so this was a difference of 2 squares. Now you don't have to write the Gcf factoring difference of 2 squares, but I'm just showing you we use 2 different kinds of factoring there. Yeah, question? Can I do number 11? Yeah, I can. Okay, so you guys okay with 6? All right, so let's take a look at 11. 11, first type of factoring. Can we factor something out? Yeah, they both have a 15. So you factor the 15 out, and you're left with what? C cubed plus 1. So I did my GCF factoring first. And that's the one you always want to do first, if you can. And then look, is there anything else that we see that we can do? What's this? A sum of 2 cubes. And again, that was from yesterday. So we have a sum of 2 cubes. Right? And so we get 15. And when we factor the sum of 2 cubes, we have 2 terms times 3 terms. And what we said is we get our two terms, our first factor, from taking the cube root of each, and we end up with c plus 1. And then to get the second one, we go c times c, which is c squared. And we think of SOAP, same sign, opposite sign, c times 1, and then always positive, plus 1 times 1. And now it's factored, and that is our final answer. So what I'm going to do with you guys, I'm going to do one from each line, okay? So you guys get to pick one from 12, 13, or 14. 12, okay? I heard 12 first. I'm going to do 12. All right. So first, number 12, first type of factoring I'm looking for is I look at all my terms and ask, is there a GCF? You see one? No. Almost, but that 5 is not even, so I can't factor it to it, right? So no. So then I think about my other kinds of factors, and I notice there's 4 terms. When you have 4 terms, what kind of factoring do we use? Grouping. So I'm going to factor by grouping. So I take half and half here. The first half I look at, now what's the GCF of the first half? X squared. And I'm left with a 2x plus 5. And then what's the GCF of the second half? A 4. But because there's a minus sign in front of that third term, you're going to use a minus sign. So minus 4. And what's left? Another 2x plus 5. We done? No, we haven't even factored it yet. And so now both terms have a 2x plus 5. Factor out that 2x plus 5. And what's left? X squared minus 4. All right, so we factored by grouping. Am I done with the problem now? No, because I got to keep looking. Is there more types of factoring that I can do? And yes, what do you see? The difference of 2 squares there, right? And so the 2x plus 5 can't do any more. And you know you can't factor anymore when you have a linear term. Linear means when x doesn't have a power other than 1. So there's no x squared. So I'm done with that 2x plus 5. You cannot factor that anymore. But here I have an x squared, so there's a possibility that I can. And so I factor it. Now, if it was an x squared plus 4, would we be able to factor it? No, remember I said sum of 2 squares does not work. Only the difference of 2 squares works. So this does factor to what? Are we done? Yes, you know that because there's no more, all terms are linear. We've got 3 linear factors there. Okay. I'll do one 15, 16, or 17. 15? Okay. I heard 15 first, so that's fine. So first type of factoring I think about is the GCF factoring. I look at all 4. Is there something I divide out of all 4 of them? 3. And remember the trick with 3, like if you add the integers, like 1 plus 0 plus 8 is 9. So I know that's divisible by 3. 2 plus 7 is 9. I could divide that with 3. Only with 3. Yes, only with 3s. 4 plus 8 is 12. 1 plus 2 is 3. So the sum of all of them, each one, is divisible by 3, so you can factor 3 out. I taught it last chapter. Yeah, but you're catching it right now. That's good. Okay, so I'm going to factor a 3 out. And when I do, I'm left with a 4z to the third plus, what's 48 divided by 3? 16. z squared minus 9z minus, how many times does 3 go into 136? Okay. Now, that 3 needs to stay out in front, and that 3 never gets multiplied. Remember, multiplication is always the opposite of factoring, so you're never multiplying when you're factoring, okay? Be careful here, because there's a lot of stuff that needs to go on with these 4 terms. We're going to factor by grouping, and so watch what I do with my parentheses as I go through this, okay? So we factored out the GCF, and now we're going to go with grouping, right? Because we have 4 terms. So I group them now. I'm going to leave the 3 out in front, and I'm going to switch to brackets. You'll see why. What can I factor out of the first 2? 4z squared. Good. And what's left? Z plus 4. And then is it going to be a plus sign or a minus sign here? Minus. And then what can I factor out of the next 2? And what's left? Plus 4. Good. All right. So I still wanted to keep everything that I'm doing here in some kind of, you could use parentheses or brackets. I'm using brackets because that 3 is still in front of all of it. Okay. Next step, I'm going to factor out that z plus 4. So it looks like this. 3 times z plus 4. And what's left? 4z squared minus 9. All right. We done? No. Still not done. Why not? A difference of 2 perfect squares. So now I'm doing a third type of factoring here. So we have a 3, we have a z plus 4, and then this is going to factor to 2 things. What? 2z minus 3, or I'll do plus 3 first, and then the 2z minus 3. All right, so we ended up with 4 factors here. Okay. Question. All right, let's look at the next line. You guys get to pick one. 18, 19, or 20? 19? All right, you guys like the 4s instead of 3s. That's fine. So first thing I do is look at all 4 terms on 19 and ask, is there a common factor of all 4 of those? No, that 7 is prime, right? So no GCF. So then I'd go with factor by grouping. Okay, so the first 2 I could factor out what? 9 k to the second. What's left? Okay. And then do I put a plus sign or a minus sign? And then what do I factor out? Just the 1. And I get another 7k minus 3. So we're factoring by grouping right now. And I'm not done yet, because now I look at both these terms and I could factor out the 7k minus 3. And we're left with the 9k squared minus 1. We done? All right, you know what to do next? We got a difference of 2 squares. So we leave the 7k minus 3. And we're going to factor the next one to what? 3k plus 1 times 3k minus 1. Okay. Are we done? Yes. Okay. All right, I'm done doing the 4-term ones. Pick 21 or 23. 21? Okay. 21. We have 3 terms. GCF, always consider that first. Is there a GCF? 3. Yes, for sure 3. Can you do what? So you know 3 works. Maybe more works, but let's do 3. Actually, let me teach you another trick. Okay? If they're all even and they're all divisible by 3, what does even mean? You can divide by 2. So if you can divide everything by 2 and you can divide everything by 3, guess what you can divide them all by? 6. You can divide them by 2 and 3, which is 6. So I'm going to divide them all by 6. So what's 24 divided by 6? 96 divided by 6? Is it 16? 90 divided by 6? Okay. And sometimes you pick something and it still wasn't enough. So still just check these 3 numbers. Is there anything else we can pull out? No. Sometimes, like if I picked a 3 and you could have picked a 3 first, you would have noticed, oh, I could still pull out a 2. And then you'd factor that 2 out and you'd end up with 6 here eventually. Okay? So always just check, make sure you got everything. And we did. So we factored out our GCF, which is nice because if I didn't do that first, when we do this next part, I'd have some pretty big numbers. I'd have 24 times 90 at the top, but now I only have to deal with 4 times 15, which is better. Okay, so I want 2 numbers that multiply to 4 times 15. What's 4 times 15? 60, okay. And we want them to add to 16. And this one I think you can do without too much trouble. How about 10 and 6? 10 times 6 is 60, and 10 plus 6 is 16. Okay? So that helps me split up the middle term. And so it's going to be 10t plus 6t here. I bring down the 15. I bring down the 4t squared. And then what's important now is to keep that in parentheses and keep the 6 out in front. Don't lose that. Okay? So now we have 4 terms. And hopefully I have enough room here. And so now we're going to factor by grouping. So leave the 6 out in front. I'm going to change to brackets here. And the first 2 terms I could pull out a 2t. And I'm left with a 2t plus 5. And the last 2 terms I could plus sign or minus sign. I've noticed some of you are doing this. I'm gonna do what some of you are doing, and then I'm gonna correct it. You just say, okay, 3 goes there, and then a 2t plus 5, and you leave it like that, and you don't put a sign in front of that 3. If you don't put a sign in front of that 3, what does that mean? That means multiplication, and that's not true. Okay, you'll be marked down if you do that. So you have to either put a plus sign there or a minus sign there at that stage. Okay, so we need that plus sign there. And then they both have a 2t plus 5, so I can get rid of the brackets now. 2t plus 5, and I'm left with the 2t plus 3. And that's it. So we did the Gcf factoring, and we did a trinomial factoring. Okay, guys, notice the nice thing on this homework. I'm not making you check them, right? So all it looks like more problems on this is probably less work on this one than on the last night's homework. Okay, but you can always check it if you wanted to, like on tests. You know how to do that. Right now, I'm not making you do that. Okay. All right. Look at 24, 25, and 26. They are looking a little more intimidating. think I heard 24 first. So I'll do 24. So I'm like, no, I wanted 26. So 24. We can vote. Want to vote? All right, raise your hand if you think it's 24. Want to go 24? Raise your hand if you want to go 26. Raise your hand if you want to go 25. All right. I think 26 won by just a little bit. Okay. No. Okay, so 26. Looking for a GCF. These are some bigger numbers. So the more we can pull out of this, the better it is later on in factoring, right? So they're all even. They look like, yeah, they all are divisible by 3, so I could at least do 6, maybe even more. You think 12 will work? All right, you tried it? Here's what I'm going to do. I'm going to do 6 because I know 6 for sure will work, and we'll see if there's more that we can pull out. Okay? So if I pull out a 6, can I pull out any A's? How many? Take out as many A's as you can. I could pick out 2 A's, so it's A squared. So that leaves 10A to the third minus, how many times is 6 going to 72? 12 times. So A squared. How many times does 6 go into 210? So if, you can do the little division here. So 6 goes into 21 3 times. 6 goes into 35 times. So 35. So right there, that tells me 12 wasn't going to work, right? Because 35 is not even. So there wasn't another 2 that I could pull out. And then I want A here. And then 252, how many times does 6 go into 252? How many? 42? Okay. And so then I look at what's left, and they don't have any common factors other than 1. And so we got everything out that we wanted to get out, okay? So we did our Gcf factoring. So now I have 4 terms left, so that's when you do factor by grouping. And so we have 6a squared out in front. Don't forget about that. I'm going to switch to brackets here, and I'm going to factor out, 2a squared, and I'm left with a 5a minus 6. Is that right? And then do I put a plus sign or minus sign? And then 35 and 42 are both divisible by what, 7? And I get another 5a minus 6, then divide by negative. Close the brackets. And now I can get rid of those brackets. I got 6a squared times, I'm going to factor out the 5a minus 6. And I'm left with the 2a squared minus 7. Now I know so I do have an a squared here, but there's really nothing, there's no plus signs or minus signs, so you don't need to factor if you don't have a plus sign or minus sign, okay? This is a to the first power, so I know I'm done. This has an a squared and there's a minus sign, so I need to just check. Does it meet any of the criteria or things that we've done before? It's a difference of 2 things, but those aren't perfect squares, so we're stuck. Okay, so that's as much as we do. But it's always good to check. Okay. Next row we have 27, 28, and 29. I'm good with any of those. So let's vote. Who says 27? Okay. So about 6 of us. Who says 28? A little more. Who says 29? All right, 28 won this one. Okay. So 28 How many terms do you see right now? I want you to see two. Right, there's one. There's the other. I want you to view it as two terms. Because really, this is a multiplication, right? And this is over here. And there's a minus sign between those two. And so look at those two terms, and what can we factor out of them? What I'm doing, this is a Gcf factoring right here in a weird way, but it's what we're doing. What do they both have? An x plus 2. All right, so if I divide that first piece by x plus 2, what's left? No, the x plus 2 goes away, and I'm left with the x squared minus 10. And I could still leave that in parentheses if we want. Minus, now if I divide the second part by one of the x plus 2's, what's left? Another x plus 2, but be careful, you have to leave this one in parentheses because there is a minus sign in front, and then close the brackets. Okay. Now the next thing I'm going to do is I could simplify this a little bit in here. God bless you. And so that's what I'm going to do. I'm going to simplify that. I'm going to distribute the negative. Don't multiply. Multiplying is the opposite of factoring. But I get x squared minus 10 minus x minus 2. And I could reorder those and add the negative 10 and negative 2, and I get x plus 2 times x squared minus x minus 12. Everybody following that okay? All right, are we done? Not sure. I'm not sure about this piece, the trinomial, because sometimes trinomials factor, most of the time they do. Sometimes they don't, but we need to try. So we did our Gcf factoring, now we're going to try the trinomial factoring. And so can we think of two numbers that multiply to 1 times negative 12 and add to negative 1? Negative 4 and 3. So if this game works, that tells you it factors. And so it's going to factor. And so we need to factor. So we got the x plus 2 we need to carry down. Never going to multiply that. We're done with that piece. It stays there. And now I got to switch this to x squared minus 4x plus 3x minus 12. So split it from 3 to 4. Sorry about the room here. Factor this out. So we got factor an x out. Factor 3 out. And I'm going to squeeze it down here. So we have the, actually I know what I could do. I will lasso it. And I will shrink it down a little bit. You can't do that? You need digital paper. See if I can do it. Come on. Doesn't want it. Oh, there we go. Maybe that's too small. Okay. So, final answer, x plus 2 times x minus 4 times x plus 3. That was a good one. I like that one. Okay. How are we doing with time? Got time for another one? Yeah, we got time. We definitely have time. Okay, now I'm going to do a solving one, and sorry, but you guys have to pick between those 4. 30? All right, I've only heard. So this is 30 here. Sorry, this is 32 here. This one? 32? Who says 30? Okay, who says 32? All right, 32. So, guys, when you solve, what's the first thing Mr. Marsh said always has to be true? has to be equal to 0. Is it equal to 0? No. So the first job is to get this thing equal to 0. So I'm either going to move everything on the right side to the left side, or I can move everything on the left side to the right side. I'm going to go right to left because my highest power is to the third, and I already have a positive number here. If this was negative, I would move it over here. I like to keep my first term positive. Okay? I'm just a positive guy. All right. So I'm going to subtract 2x from both sides. And I'm going to subtract 3 from both sides of this equation. So when I do that, these zero out, and I'm just left with the big 0 over here. Okay? Now notice I said subtract, but I really can't subtract any of these because none of them are like terms. So I just end up with 4 terms on the left side. And so I get 2x to the third, I'm going to put them in order, plus 3x squared minus 2x minus 3 equals 0. So first step, make it equal to 0 always when you are solving, no matter what kind of problem you're working with, okay? What's the second step? Factor. And you think about what kind of factoring. So first you look at all 4 terms. Can I factor out a GCF? No. But we can factor, we can try factoring by grouping, and we hope it works. Otherwise, we wouldn't be able to solve this. And so we can factor out a what? X squared, what's left? Okay. And then plus or minus sign? Minus 1, get another 2x plus 3. Don't forget the equal 0. You got to carry that with you. And then you keep factoring. I could factor out a 2x plus 3 from both of these. And I'm left with an x squared minus 1 equals 0. Can we factor more? Keep factoring if you can. And that's a difference of 2 squares. So we got 2x plus 3, x plus 1, x minus 1 equals 0. Okay, so first step, set it equal to 0. Second step, factor it. We did both those steps. What's the last step? Separate all 3 factors and set each one equal to 0 and solve. Okay? So we have a 2x plus 3 that we can set equal to 0 and solve. We have an x plus 1 that we can set equal to 0 and solve. And we have an x minus 1 that we can set equal to 0 and solve. So this one gives us x equals 1, x equals negative 1. And I don't know how good you are doing these in your head, but what would this one give you? Negative 3 over 2. So don't do that one in your head. Write it out. Okay. So there we go. Those are our 3 answers to this problem. Okay. Let me address one thing here with factoring. Say you're solving and you do all this work and it factors to this. 2 times x plus 1 times x minus 2 equals 0. Right? And you want to solve for x. And you have these 3 factors. What would you do next? Set what to 0? Okay, x plus 1 equals 0. What else? Okay, what else? What do we do with the 2? It's a factor in and of itself. So I don't want to multiply because that would be the opposite of factoring, right? Just, because you're talking about multiplying, right? Here's what you do. If it doesn't have a variable, you ignore it. It doesn't help you. So I'm going to clarify one thing. When I say set your factors equal to 0, I'm meaning set your factors that have a variable equal to 0. If it doesn't have a variable, it has no bearing on your solution. Okay? So just So I think I'm done, and I'm going to leave the rest in your hands. All right? So have some fun factoring.